My gosh, especially if I'm recording this.
Okay, so we're going to do number 4. If you have no interest in paying attention, you are like 100, you better be 100% confident if you're not going to pay attention. You're welcome to move ahead. But a lot of kids like a review of each one of them. So let's look at number 4. I'm going to call on some of you. We're just checking for understanding as we go. So this one specifically says you have to show me that you know how to solve by factoring. So if you solve this one a different way, part of your credit is going to be that you've tried the factor. All right. And what do I do if I want to factor this? Say it again. Yes. Eliza, what else would you do? Yes, most of these you want them to be, I shouldn't say most of them, some of them, you want it to be in standard form. So we know A times C, B. Right now our C is on the wrong side of the equal sign. So before we put them in Ian's X, I would move that 16 to the other side. And then this one's a super easy one because there's lead coefficient is a 1. So I don't really have to do A times C. So these ones are fun to factor when the lead coefficient is not a number bigger than 1. All right, Emma, what two things multiply to be 16 and add to be negative 10? You're fine. I can be patient. Everyone else is thinking of them too. Yes. So they multiply to be a positive 16. They add to be a negative 8. There's two things you can do now. There's a shortcut to go straight to the solutions. I'm going to pick on someone else. Maddie, do you remember what the shortcut is to go straight to the solutions? That's the long way to it. This will get you the answers. It's just the long way. All right, so you set them equal to 0 because we're finding the zeros. We're finding the roots. Does anyone remember the shortcut now? Yeah.
You just take those numbers that we factored just to the
Opposites. Both of these are fine, but if you can remember the shortcut, it'll just save you what? 2 seconds? That took me to write that down. It doesn't save a lot of time. Okay, so 1, 2, and 3 are very similar to number 4. Do the factoring tree. In fact, all of their lead coefficients are 1, so we don't even have to divide by anything. Okay, the next one, any questions on this before I move on? Yes? So we are trying to find, we aren't just factoring it, we're trying to find the roots, the x-intercepts. And we find an x-intercept when y equals 0. So this is where the 0 came from. And then I'm adding 8 to both sides. So x equals 8. I'm adding 2 to both sides. That's where I got the x equals 2. Good question. All right, I'm going to do number 8 now. And this one's by taking the square roots. So right now, if you're not like, oh, I know exactly what to do, then I want you to point at your p squared and maybe write some type of a note that says, when you're solving using this square roots, which that's what you're doing in this section, we have to get whatever is being squared alone. We don't just square root right now. That wouldn't make sense. We have to get the p squared all alone. Jada, how might I get that p squared by itself over there? Yes, so your basic two-step equation. So Carlos, now that we've isolated the p squared, how do we solve this using a square root? What do we do? I didn't turn my timers off. How do I get rid of the squared? What's the opposite of squaring? Yeah, sure. Allie, what's the opposite of squaring? David, third time's a charm. David, what's the opposite of squaring? The check. I think it's called the check. The opposite of squaring is the square root. So up here by the directions where it says solve each equation by taking the square root, put this right on top of that word in your directions. So if you're like I can't imagine these are the only two that weren't really sure what to do. I'm guessing there's a few more. So in the directions, put that over the top of it. So when you get stuck, you'll remember those are opposites. Okay, if they're the opposites, then I should have a p by itself. Am I on? Lainey, or Lacey, what do I need to do to make sure this answer is perfect? Like from here to here. Is it just the square root of 19? Is that the answer? Yes. If I was a high school student again, actually, I'm a high school teacher. I still forget sometimes. That's something really easy to forget, that it could be a positive square root of 19 or it's also the negative square root of 19. We have two roots on most of these. Parabolas are a u. They're going to cross it twice most of the time. Yes? Yes. Yes, I don't know if you guys all heard. She said if we get to the very end of the problem and it's a perfect square, then your answer would be a positive 5 and a negative 5. You can write it a few different ways. You can write it a couple different ways. This is a new way you're probably a little uncomfortable with. This looks better to our brains. Can the square root of 19 be reduced, or is it perfect? If you're not sure, try to make a factor tree. What goes into 19? Nothing. 1 and 19. So if the only things that go into it are 1 in itself, this is a perfectly good answer. So I would put somewhere, put that symbol over. Maybe you can even come in and do that so you won't forget that on the test. I can't give you full credit if you tell me the answer is the square root of 19. That's half wrong. Huh? Open what? No, because I'm giving you a review day. All right, solve using completing the square. I think this one is the most confusing to students. But we've seen parts of it twice now. My concern is if you're just trying to memorize steps, it's a lot. Maybe. Okay, where did I leave off? Keegan, I need to complete the square. So to everyone first, completing the square means that if I were to do the factor x with this, these two values would be perfectly identical. So that I can write it like that. Like I'm trying to create that. So this is not, if I do the negative 94 and negative 8, that is not going to create perfect numbers. Okay, so we're going to start messing around with this to create that situation. All right, Keegan, what should I do first on this one? Other way around. Yes, this 94, it's not the right number. It's not completing the square like we want it to. We're going to get it out of the way for now. I'm leaving a space here because I'm going to find the perfect number. So I'm leaving that space on purpose. Ashlyn, I know you missed some days, so if you're not sure what to do next, just let me know. How do I find that magically perfect number, Ashlyn? Yeah, sure. Ethan, do you remember what I have to do with this to find that magical number that will give me this perfect square trinomial? I'm going to give you a hint. What do I find half of? 8. Half of b, in this case, b is negative 8. Ethan, what else do I have to do to that number to find that perfect square trinomial number? Not sure. Okay. We're to you, Sophie. What do I have to do to it? I got to square it. And Josh, what do I do with that 16 now that I found it? We add it to both sides. Do some of you feel like you have some studying to do, or are some of you like, woohoo, I'm ready? I can't tell. So we got the 94 out of the way. It was not that perfect number. We needed it to say plus 16. It did not. So we got it out of the way. We figured out what that number was, so that when we factor, we get the same number here and here. That's what we want. So we can write it like this, because now we can solve using the square root. When you complete the square, we are taking a situation and making it so that we can use square roots to solve it. During second period, I could not add 85 and 16 in my head. It would not work. I kept getting stuck at 99. It wouldn't go past it. Okay, any questions with what I've done so far? It is a lot of steps. So if there's any part of you that can understand what the heck we're doing, it'll be easier than just trying to memorize them. So we got this out of the way because we need a perfect A, B, C. We need a perfect C so that when I factor, I have the same thing twice. And 16 is the right number. That's what we needed. We did not need negative 94. And then now that we've factored this perfect square trinomial, Mallory, what can I do to solve using square roots? Yes. Now this is very similar to 5, 6, 7, and 8. The square and the square root are going to cancel each other. I'm not going to forget my plus or minus. Almost done. We almost have the k by itself. Jesus, what else do we need to do to get that k by itself? It's not a perfect square root, but we do need to get rid of the minus 4. How do we do that? The way that we write these is we put the whole number first, which is a 4. Then we put the plus or minus, and then we put the square root of 101. I would try to put it in your calculator. I would check to see if it can factor out. I don't think it can. So if you can't simplify that square root of 101 at all, that's your final answer. We completed the square, so we were able to use square roots to solve. Any questions on that one? Make sure you practice these ones and take good notes, and then we'll look at it just for a second before you take the test tomorrow. What do I do next? Make sure you know the answer to that. Okay, the next section is solve each equation with the quadratic formula. We've already done like 3 of those today, so I'm not going to do any of those. And the bottom section, from 17 to 26, you get to choose what method you want. If you have even with that blue sheet, if you have no idea which method is best, use a quadratic formula. It works every single time. Some of them are easier to factor or to use the square, but most of them. Okay, so I need you all to do 1 through 16. I've already done 4 of those. You have to do all of those. And then from 17 to 26, if you feel like you're running out of time, just choose 5. Whoa. Put that down somewhere on your paper. So definitely 1 through 16, do all the rest of those. But the ones that say that you get to pick your method, pick 5. Okay, you have until 55, 5, 10. You have 15 minutes to try to get these done.